less. We've got the transmission out of your 2004 Dodge 3500. This is what it looks like when it's all apart. I'll go over some things with you, and Eric or Amanda will contact you with the cost estimates. This way you get to see what the inside of the transmission looks like. We'll start with the pan. You can see the magnet. There's metal that's been attracted to the magnet. That's about 4 times the normal amount. You can see that you can pile that up. That's going to be extra wear that's not supposed to be there. As far as the clutches are concerned, this is the rear clutch comes on for all the forward gears. It really wasn't slipping. You can see a uniform color on the steel plate, and the friction is a uniform color as well. This is the overdrive clutch, comes on for 4th gear. It hasn't been slipping either. You can see the uniform colors there. This is the overdrive direct clutch. When we get over, same thing, these are one-sided clutches. They haven't been slipping. When we get to the front clutch, which comes on for 3rd gear in reverse, we do see some slippage. You can see the black line on here, and then you can see some darkening on the steel plate here and here, and that's from extra heat that's generated from the actual slippage. This is the range sensor. There's oil inside of here, and that oil is going to basically come through here, in here, come out here, in this cavity. It's an electrical connector. There shouldn't be any oil, and basically we're going to replace this because of the contamination there. The washers themselves look okay. When we get to the bearings, the camera's not going to pick up the bearing wear, but there are lines that go like this, and that's the beginning of the pitting of the bearing. So this bearing is in the early stages of failure, as is this bearing here. And this bearing has very little, well, the camera definitely won't pick up this one, but again, there's the starburst pattern on the bearing that indicates that it's starting to pit. The planets, this is the overdrive planet, it looks okay. Sun gear has some pitting. This is our front gear set and the rear gear set. They look to be okay as well. We look at the pump. No scoring on the gears. It looks like it's going to be okay. We have to clean it up and measure it still, but it looks like it'll be okay. This surface we have to flatten. Quite often they're warped, so got to make sure that's flat. The band. This band comes on for 2nd gear. This early brown lining is known to wear out, and yours is no exception. The lining is wearing off, and what you'll end up with is no 2nd gear. So the new band is a dark green high energy lining that wears much better and is a lot more durable. The lower reverse band is this one. It hasn't been slipping either, so as far as this band is concerned, we know that it didn't slip in reverse. When we get to the valve body, if we look down at this ball, right down here, the ball, you can see the detents here. When you change the different gears, these detents are what you're feeling. And the ball wears in the pocket, so the ball is just supposed to move back like that and come back and then engage into these detents. But on these later units, the casting's a little soft, and so what happens is the ball moves like this in the bore, and it can cause mispositioning of the manual valve. So I'll try to get a shot of the ball movement. That's too much movement there, and what we do is we bore out the hole, we put a sleeve, and then we put a ball in there into the metal sleeve, so we don't have that wear issue. The problem is that controls the positioning of the manual valve, so it's important where this valve is actually situated. On this side, we've got the governor solenoid. We've got an updated governor solenoid that we're going to put in there. It's larger than this, and it's about 15% stronger magnet in it, so it is a much better piece. This is the transducer. This tells the computer what pressure the governor solenoid was actually producing, and they're known to fail as well, so we're going to put a new one of those in also. The valves here, we've got a manual valve. We have a new design manual valve that fills the torque converter in part, which adds to the durability. The pressure regulator valve is going to be in here. We put in one that has a line to lube modification. Again, it's for durability, and the last last one here is a solenoid switch valve, and it's a little different design that engages the torque converter quicker, so we get a more positive lockup feel and a better clutch ply. So there's also some hole sizes that we're going to change in the valve body to create a bit of a quicker shift. We don't want a bump shift, but we want the shifts to be nice and fast. So that's basically what the inside of the transmission looks like, and now you know what we found inside. Thanks.